here, this is still in the same section. They're asking for a random sample of gas taxes is shown for 12 states. Use the data to estimate the population mean gasoline tax with 90% confidence. Less than 30, we're using the T, okay? Well, I don't want to write T next to that, but I know I'm using the T test. This is my N, okay? I know that it looks more like an H, but sorry. Again, I have to type all this data into my calculator using the stat thing to figure out my X bar and my S. So X bar is going to be 43.49, okay? And my S of X is going to be 9.2. From here, I have N is equal to 12. So to figure out my degrees of freedom, they're 11 because it's 12 minus 1, and I get my little formula for this. I'll just do the first part like I've been doing. 43.49 minus 1.79, that's what my T is, times 9.2 all over the square root of 12, less than mu, blah, 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 okay? Punch that in, and you should end up with letter C. Now the next question says, does your interval contain an average? Well look, is 44.7 in between 38.7 and 48.28? Yes. So that's that one. Alright, let's look at number 3. It says here, a recent survey of 8 social networking, 8, we're using the T, and then this is my N, has a mean X bar, standard deviation, S of X, okay, and 95% confidence interval. Again, I need to look in the book and do degrees of freedom are 7, look at my 95% confidence interval, and I should end up with 2.16 for T, okay? If I go ahead and, oh, I'm sorry, that's totally the wrong problem I'm looking at. Sorry, 2.365. And so in this case, it's going to be big when you type this in the calculator for 13.1 million. Don't do 13.1. Please do not. You got to put that big old number in, minus 2.365, and then, yes, 4.1 million for your standard deviation all over the square root of 8. And then, of course, your in between mu and your other one with the plus. You end up with this number. 9,671,769 in between mu. I'll write the other one. It comes out to be 16,528,230. So of course they round it to get A. Okay, just putting that out there. That's what the number would be. These are not the easiest problems. Believe me, I am very well aware of that. Now, this next one, same type of stuff, okay? Same type of stuff. They're giving us 100 problems for every section here. 14 is N. 33.2 is the X bar. Standard deviation, there we go. 95% confidence interval. My degrees of freedom is 13. And I need to look up, and in this case, this is the one I was looking at, my T is 2.16. So again, my formula, 33.2 minus 2.16 times 8.3 all over the square root of 14 in between mu, in between blah, 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 and you should end up with B. Last but not least, again, you got to figure out what your X bar is. That comes out to be 51.25. Got to figure out what your sample standard deviation is. 47.5, okay? And here, you count how many there are. N is equal to 17, sorry. So then your degrees of freedom is 16, and you look that up, your T is equal to 1.746. Go ahead, use your formula now. 51.25 minus 1.746 times 47.5 all over the square root of 17 in between mu, the other one. And you should end up with, in this case, probably because I didn't round this up to a 0.3, I get a little lower, but it is A. Okay, if you're off by a little bit, it's okay to figure out which one it is. Alright. Now this is moving on to 7.3. Okay. Now 7.3 is about the P. It's a little different. Same type of stuff, but just a little different. If we notice right away a survey of 1,721 people, hey, we're not using that teacher, okay? So in this case, we're going back to Z. So 95% confidence interval, my Z is equal to 1.96, all right? Now here's the deal. This is the P hat and Q hat, okay? P hat is this is as a decimal, make that 0.159. Q hat is 1 minus whatever your P hat is, which in this case is 0.841. So from here, I go ahead and I plug these into the formula, and I hate to do this, but I'm going to need some room over here. The formula for this is, I'm actually going to write it over here, this is really bad. P hat minus Z alpha over 2 times the square root of P hat times Q hat all over your N. Okay? So in this case, I have 0.159 minus 1.96 times the square root of 0.159 times 0.841 all over 1,721. And again, it's in between mu and between the same thing with the plus. Same thing we're doing. Punch that in the calculator and you should get A. Alright? Now the next question is asking us to find P and Q. Well, in this case, you take your X and you divide it by N, whatever it is, for P. 40 over 80 is 50. Q is going to be the same thing, 50-50. They have to add up to 1, okay? For the next one, I do 35 out of 60, which ends up being 0.583 for P hat. And then I do 1 minus 0.583, that gives me 0.417. That's my Q hat. I know this is quite a mess. And this one, 43 out of 95 for P hat gives me 0.453. Q hat is going to be 1 minus 0.453, which ends up giving me 0.547. So hard to see. I hate to do that. Okay, there they are. All right, number 3. Okay, that's my N. Here, 39, I'm going to make that a decimal. P hat is equal to 0.39. Q hat is 1 minus 0.39 always, which is 0.61. Check my 95% confidence interval, it's 1.96, so 0.39 minus 1.96 using my formula times the square root of 0.39 times 0.61 all over 1,500. Boom. Less than mu, less than blah, blah, blah. Plus on the other side, always. And you should end up getting that answer. Scroll down. Okay. Okay, here it says 205 and 65 responded yes. They don't give me a P hat, I need to find it. So P hat is going to be 65 out of 205, which as a decimal ends up being 0.317. Q hat is 1 minus that, which gives me 0.683. Okay. Now, 99% confidence, so 0.317 minus 2.58. That's my Z for the 99% confidence times the square root of 0.317 times 0.683 all over 205, and of course I have my less than mu and then the other one, and when I punch all this in, I should end up with C in this case. Going on to the next one here. It says here a survey of 200 workers, 168 said that they were interrupted, and then 90% confidence interval. Okay. So here what we're going to do is P hat is 168 out of 200, which comes out to be 0.84. Q hat is 1 minus 0.84, which is 0.16. For 90% confidence, I'm using a Z of 1.65. And then I'm just going to copy everything else here. Times square root 0.84 times 0.16 all over 200 my n. Of course, I have my plus on the other side, and I should end up with A for my answer. I'm going to stop it before I go to the next three on the back.